Hello, my dear students. Welcome to the session. Continuation of important observations from power electronics concepts. I am discussing power semiconductor devices concepts. In this session, first I am going to starting turn-on methods to transistor analysis of SCR. Students, we know that the process of bringing the SCR from forward blocking mode to forward conduction mode is called turn-on of SCR. To bring the SCR from forward blocking mode to forward conduction mode, there is so many methods are there. Those methods are called turn-on methods of SCR. One is forward voltage triggering method, gate triggering, temperature triggering, it is also called thermal triggering, light triggering, EV. But here very important point that you have to remember. Among all the triggering methods, gate triggering is more preferable. But we don't use forward voltage triggering practically. Even temperature triggering is also not preferable practically. One of the main drawback of temperature triggering is it causes thermal runaway. It leads to thermal runaway. Leads to thermal runaway. It's the worst triggering method. That's why we never prefer this thermal triggering method. Forward voltage triggering not preferable practically because high forward breakdown voltages may damage the SCR. Temperature triggering is also not preferable practically because it leads to thermal runaway. Even dV by dt triggering is also not preferable practically because it causes unwanted triggering of SCR. Practically, only two methods are preferable. One is gate triggering, another one is light triggering. But which is more preferable practically? Gate triggering. But light triggering, mainly we are using in HVDC converter. HVDC converter. Friends, we know that in HVDC converters, we are using LASCR. That is light activated SCR. The SCRs which utilizing the light triggering, those SCRs called LASCRs, light activated SCRs. Those LASCRs we are using in HVDC converter. These points mainly have to concentrate. Before starting the what exactly detailed discussion of light triggering and gate triggering, first we have to concentrate what the two transistor analysis of SCRs. Mainly this gate triggering and temperature triggering we can clearly understood by using the two transistor analysis of SCR. According to two transistor analysis of SCR, SCR is equivalent to back-to-back connection of two twin transistors. This is important. This point mainly you have to concentrate. According to two transistor analysis, this is the transistor modeling. SCR is equivalent to back-to-back connection of two twin transistors. Which are the twins here? PNP transistor and NPN transistor. Now the question is, sir, why two transistor modeling of SCR is developed? The two transistor modeling of SCR explains the turn on of SCR. How the SCR will turn on, that can be explained by using the two transistor analysis. This is the equivalent circuit. It is a back-to-back connection of two twin transistors. One is PNP transistor, another one is NPN transistor. In this concept, mainly you have to concentrate this is the IC1 equation. That is the transistor 1 collector current equation. Transistor 2 collector current equation. That is IC2 equation also you have to remember. That is also very important. Then anode current equal to sum of the two collector currents. Anode current equal to sum of the two collector currents. That point also you have to consider. Then cathode current equal to anode current plus gate current. This whatever the formulas that I given. Because it is a quick revision, I am not giving any derivation part here. But here whatever the points, formulas I given, that formulas mainly you have to concentrate. That is IC1 and this is the IK and this is the anode. What is the observation here? According to two transistor analysis, the anode current is equal to sum of the two collector currents. Cathode current equal to anode current plus gate current. And we also remember IC2 equation. This is the collector current of T2 transistor. Once you know the IC1, IC2 and IK equation, then by deriving this formula, finally you can get this expression. Whatever I am giving the formulas, 5 star, that formulas only you have to finally concentrate. That is according to two transistor analysis, how this anode current depends on gate current, leakage currents. Anode current depends on gate current and also leakage currents, where alpha 1 and alpha 2 are the current gains of the T1 transistor and T2 transistor. The final conclusion point here, if alpha 1 plus alpha 2 tends to unity, IA tends to infinity, hence it is called latching device. This is the proof, very important. SCR is a latching device because if this sum is tends to unity, IA tends to infinity, that's why it is a latching device. This statement you have to remember, this formula also you have to remember. By using this equation, we can clearly understood what exactly gate triggering and what exactly temperature triggering. We can also prove that SCR is a positive feedback control device or regenerative device. Friends, very important points you have to remember. SCR is a, we already know semi-controlled device. Semi-controlled device. Here is this control device. And it is a latching device. Latching device. Here is a latching device. And it is a positive feedback control or regenerative device. Positive feedback is also called regenerative feedback. Positive feedback control device. Positive feedback controlled is also called regenerative device. These statements are important. By using this final equation, we can understood the gate triggering and also temperature triggering. And we can also prove that SCR is a positive feedback device. Among all the triggering methods, gate triggering is more favored. I told already. SCR is a charge control device or current control device. Only in gate triggering, the gate supply is connected. In remaining triggering methods, no need to connect gate supply. This is also very important. That is, SCR turn on without gate signal also. That is remaining triggering methods. Forward voltage triggering method, temperature triggering method, even light triggering method, dV by dt triggering method. No need to use any gate supply. Only in gate triggering only gate supply is required. This question is important. Can you turn on the SCR without gate supply? Yes, we can turn on. There is so many methods are there. Light triggering is used in HVDC transmission. SCR under forward blocking mode is equivalent to capacitor, that I told already. Under forward blocking mode, SCR is equivalent to capacitor. All these points mainly you have to concentrate. This is about the turn on methods of SCR. Based on these turn on methods, I given some practice questions here. Please go through this one. Just for your preparation point of only that I given. Answers also I given. Please go through. For quick revision point of view, I don't want to explain all these problems detail once again. Already know. Please go through this. And this problem also you have to concentrate. With whatever the points I given, with that knowledge, try to solve this point. And this problem also you have to concentrate. This is, if SCR under forward blocking mode is equivalent to capacitor, one more capacitor is connected here. Parallel combination of capacitors are added directly. From that you have to calculate the I equal to C into dV by dt. From that you have to calculate the dV by dt. This is also one problem that you have to concentrate. Next. With this turn on methods, two transistor analysis concept, important observations are completed. One more topic with respect to SCR, dynamic characteristics of SCR. From the dynamic characteristics, these are also called switching characteristics. Dynamic characteristics are also called switching characteristics of SCR. From these switching characteristics, you have to concentrate important observations. The switching characteristics are again turn on characteristics and turn off characteristics. Friends, we know that turn on is nothing but bringing the SCR from forward blocking mode to forward conduction mode. Turn off is nothing but bringing the SCR from forward conduction mode to forward blocking. First, we have to concentrate turn on characters. Point to remember, friends, the total turn on time of SCR is divided into 3 times. That's why the turn on time equal to delay time plus rise time plus spread time. At this point mainly you have to concentrate. What the turn on time of SCR? Delay time plus rise time plus spread time. What is the observations from delay time? During delay time only, by controlling the gate current, delay time is controlled. Very important. By controlling gate current, only delay time is controlled. But TR and TS is unaffected. What is the meaning of by controlling the gate current, delay time is controlled? If the gate current is increases, delay time is reduced. That is within less time, the current is reaches to 10%. You know that during delay time, current is rise to 10% of total current. If you increase the gate current, if you trigger the SCR with high gate current, within less time the current will be rise to 10%. That is, by increasing the gate current, delay time is reduced. But TR and TS is unaffected. TR and TS unaffected. Unaffected. That is, by controlling the gate current, we cannot control the rise time and spread time because already the J2 junction is saturated. That's the reason why. Only delay time is controlled by controlling the gate current. Yeah, this observation is important. Next, what is the observations from rise time? Very important point that you have to concentrate. During rise time, the power losses are high. During rise time only, power losses are high. This one point to remember. That is high power losses. Power losses are high. And one more observation. During rise time, during TRR, or during TR, not TRR, during TR, DI by dt is high. And even dV by dt is also high. Because of this reason, during rise time, to reduce the di by dt, we have to use in series with the SCR an inductor or saturable reactor. And spread time, during spread time, the current is rising to 90% IA to 100% IA. 100% IA. Voltage is falling to 10% VA to on-state voltage drop. On-state voltage drop. In detail about this definitions, you please concentrate this waveform. During this is delay time, this is rise time, this is spread time. During delay time, rise time, spread time, how the currents are changing, that is the definitions for delay, rise time and spread time. How the voltages are changing, that is also definitions for during rise time, delay time and spread time. This drop is called on-state voltage drop. On-state voltage drop. During which time the power losses are high, that you have to concentrate. This is the rise time. What this time, friends? Rise time. During rise time, the power losses are high. That observation is important. And very important observations from turn-on characteristics of SCR. How this turn-on time will depends on different parameters. Very important. Very important that you have to consider. Turn-on time depends on the nature of the circuit or nature of the load. For RL load, students, the turn-on time is high. If inductance is increases, turn-on time is also increases. Very important. If inductance is increases, di by dt is reduces because inductance opposes the rise of the current now. That's the reason why di by dt is reduces. Di by dt reduces. To rise the current, it takes more time. Turn-on time is increased. This is one observation. If inductance is increases, turn-on time is. That's why, for example, if there is a two SCRs are there, One SCR is connected for 5 millihenry inductance. Another SCR is connected for 50 millihenry SCR. Both are same rating. Let for this SCR turn on time is T1. For this SCR turn on time is T2. Then which SCR turn on time is more? For this T2 greater than T1. If inductance is more, turn on time is more. That is for inductive loads, the turn on time is more. The SCR is connected in inductive load. It takes more time to turn on. But what about in RC loads, capacitive loads? For capacitive loads, initially capacitor acts as a short circuit now. That's why di by dt is high. Once the rise of the current is high, whatever the rise time? The rise time is less. Once the rise time is less, what the turn on time? That's why for RC loads, turn on time is less. For RL loads, turn on time is high. Like this, the turn on time depends on the nature of the loads. It also depends on the magnitude of the gate current. Very important. If the gate current is increases, you already know delay time is reduced. When the delay time is reduced, turn on time is reduced. No doubt at all. By increasing the gate current, there is no effect on the rise time and spread time. It will not affect it. But here delay time is reducing now. Once the delay time is reducing, what the turn on time also reduced? Because turn on time depends on the delay time. But point to remember, students, for example, two SCRs of same rating, one SCR is designed for gate current of 100 milliampere, the another SCR is designed for gate current of 2 amperes, then which is having the less turn on time? The SCR which designed for high gate current, which are triggered with high gate current, that SCR is having the less turn on time. But some SCRs are designed with high gate current. Those SCRs are called hard to fired SCRs or overdriven SCRs. Very important observation. For hard to firing or overdriven SCRs, what the turn on time? That is a 2 to 3 microseconds. The turn on time is a 2 to 3 microseconds for hard to fired or overdriven SCR. Hard to firing or overdriving of a thyristor reduce its turn on time and enhance its di by dt capability. If any SCR is triggered with high gate current, its turn on time is reduced and di by dt capability is also increases. These observations are important. Like this, turn on time depends on the magnitude of gate current. It also depends on the gate signal wave shape. Very important observations, friends. To reduce the turn on time, what type of gate signal is preferable? To reduce the turn on time, what type of gate signal is preferable? To reduce this turn on time, high frequency, high amplitude, narrow pulse width, rectangular pulses are more preferable. This is very important. To reduce the turn on time, what type of signals, gate signals are preferable? This is important question. High frequency, high amplitude, narrow pulse width, rectangular, that is a sharp leading edge, rectangular pulses are more frequent. But very important observations, friends. Due to high frequency pulse triggering, not only reduction of the turn on time, the size of the pulse transformer is also reduced. The question is asked like this. Due to high frequency pulse triggering, turn on time is reduced, the size of the pulse transformer is less, both A and B, then that is the correct. Both A and B is not there, your preference is the size of the pulse transformer is reduced. That is the first preference that you have to consider. And one more important observation, turn on time is also depends on the temperature. The SCRs which operating at high temperature, it takes less turn on time. That is, if the temperature is increases, the turn on time is also reduces. We know that during turn on of SCR, current is rising. Let assume that ideally. Practical characteristics already given. Let these are the ideal characteristics. Current is rising, voltage is linearly falling and linearly rising. For linearly falling and linearly rising characteristics, how to calculate the average power loss that I told already? 1 by 6 VA, voltage into current into turn on time into frequency. For this type of characteristics, directly you can write average power loss. If it is asked energy loss, don't take F. Don't multiply with frequency. I told already. The only difference power loss and energy loss is without frequency energy loss, with frequency power loss. Like this, the turn on time depends on different parameters. This is about SCR turn on characteristics. Here I given some questions. Please go through this one. Whatever the points I given, based on those points, finally you have to solve these questions only. My suggestion is, students, whatever the points I am giving, please go through these points. Whatever the questions that I given, just practice one time. That is your final preparation of power electronics for your GATE exam. That is enough. This question also you have to practice. Whatever the points I given, regarding that point, you please go through this question and solve this one. This also you have to practice. Just now I given the formula. Then here I solve the detailed solution also I given. Once again, please go through this one, this model of question. One more important characteristics of SCR is, this is also one of the switching characteristics. That is the switching characteristics during turn off. These are the turn off characteristics of SCR. Turn off characteristics of SCR. Characteristics of SCR. Turn off characteristics of SCR. What do you mean by turn off of SCR? The process of bringing the SCR from forward conduction mode to forward blocking mode is called turn off of SCR. Technically, the process of turn off of thyristor is called commutation. Process of turn off of SCR is called commutation. It's very important that you have to do. We know that to turn off the SCR, what you have to do, students? To turn off the SCR, you have to apply reverse voltage and current is reduced below some minimum value of current. That current is called holding current. We are bringing the SCR from forward conduction mode to forward blocking mode by applying the reverse voltage. That is nothing but a turn off of SCR. In turn off characteristics, mainly the device turn off time equal to reverse recovery time plus gate recovery time. This formula you have to concentrate. No need to concentrate all the points. What is the device turn off time? The device turn off time equal to reverse recovery time plus gate recovery. During reverse recovery time, what happening? That is whatever the charge carriers in the layers and J1, J3 is removed. During gate recovery time, whatever the charge carriers at J2 junction is removed. This is during TGR time. This is during reverse recovery time. This happens. That is what the device turn off. Next, what the circuit turn off time? What the device turn off time? What the relation between these two? That is very important in gate point of view. Already questions are framed. Here I given the what is the definition of the device turn off time. Okay, that you have to concentrate. The turn off time TQ of a thyristor is defined as the time between at the instant anode current becomes 0 to and the instant SCR regain its forward blocking gap. Very important. The question may be expected like this. The turn off time of SCR is defined as, it is time taken by the device to complete its turn off process. This is one more definition. During device turn off time itself, anode current is reduced below the holding current. Very important observation. Device turn off time itself, current is reduced below the holding current, not during circuit turn off time. Device turn off time itself only it is reduced. But even though current is reduced below the holding current during device turn off time, some extra time we are applying the reverse voltage. That extra time is considered as a circuit turn off time. Why we are applying some extra time? For reliable turn off of SCR. The device turn off time I told already, reverse recovery time plus gate recovery time. Then what the circuit turn off time? Based on the definition of circuit turn off time, already question is there in gate exam. It is time taken a reverse voltage applied across one device in one cycle, one time period. How much time reverse voltage is applied across the device, one cycle or one time period? That is called circuit turn off time. The thyristor's turn off time TQ is applicable to an individual SCR. In actual practice, thyristor form a part of the power circuit. The turn off time provided by the thyristor by the practical circuit is called circuit turn off time. That is whatever the time given by the circuit to the device. See the definition, students. Time taken by the device is device turn off time. Time given by the circuit to the device, that is nothing but a circuit turn off. And this one more definition for circuit turn off time. It is defined as the time between the instant anode current becomes zero and the instant when the reverse voltage due to practical circuit reaches to zero. That is up to what time we are applied the reverse voltage across the device. The reverse voltage across the device or SCR. That is nothing but a circuit turn off time. This is very important. For reliable turn off of SCR, what the relation between the circuit turn off time and device turn off? Always circuit turn off time must be greater than device turn off time. At this point mainly you have to consider. If any safety factor is given, how to calculate the circuit turn off time? Circuit turn off time equals safety factor into device turn off time. This observation is important if any problem is framing in commutation methods. Sometimes in commutation methods, solving of the problems, they will give the safety factor. Then you have to calculate the circuit turn off time, safety factor into device turn. That you have to consider. The turn off time is influenced by the magnitude of the forward current. That is how the turn off time will depends. Di by dt at the time of commutation and junction temperature. But turn off time decreases with an increase in the magnitude of reverse voltage. This is important. If you apply the high reverse voltage, within less time, the device will be turned off. Turn off time TQ is not a constant parameter of thyristor. It is not a constant parameter. And point to remember, students, both turn on time and turn off time depends on junction capacity. Not only on temperature, it also depends on the junction capacitor. Temperature it depends, junction capacitance is also depends. If temperature is increases, turn off time is increases. But if temperature is increases, what the turn on time is decreases. This is important. If reverse recovery voltage is increases, device turn off time is decreases. All these points are very important observation for statement based questions. For any SCR, which time is greater? Not only SCR, students, for any device, always off time is greater than on time. Device turn off time is greater than as compared to turn on time. This observation also that you have to concentrate. Based on the turn off time, the SCRs are classified into two types. One is converter grade SCRs, another one is inverter grade SCRs. Very important observation. For converter grade SCRs, what the turn off times? Converter grade SCRs are having high turn off time. That is 50 to 200 microseconds or greater than 50 microseconds. Even 50, sometimes they will give the 50 to 100 also. 50 to 100 is correct, 50 to 200 is also correct. Both are given, you select the 50 to 100 microseconds. The 50 to 100 microseconds is not given, you select the 50 to 200 microseconds. That is, the SCRs which having the turn off time is greater than 50 microseconds, those are converter grade SCR. These are used only for low frequency application. Why? Because whose turn off time is more, frequency of operation is less. Then where we can use this converter grade SCR? Phase control rectifiers, AC voltage controllers, step down cycloconverters. They are using this converter grade SCR. That is the converters which are used for low frequency applications. In those applications only we can use the converter grade SCR. The next one is inverter grade SCR. The SCRs which having the fast turn off time, very less turn off time. Those SCRs are called inverter grade SCRs. For those SCRs, the turn off time is 3 to 50 microseconds. That is, the SCRs which having the turn off time is less than 50 microseconds. That is inverter grade SCR. These SCRs are costly SCRs as compared to converter grade. And these are preferable for high frequency circuits like inverters, stoppers, forced commutated converters, step-up cycloconverters. How to use SCRs. This is about what exactly dynamic characteristics of SCR or switching characteristics of. With respect to switching characteristics, I given the observations from turn on characteristics and turn off characteristics. Please go through that point. And based on this, I solved some questions. Please go through these questions, friends. Whatever the points I given, with that knowledge, try to solve these questions that I am leaving for you. This also you have to try to answer these questions. This also you have to try to answer these questions. Yes. And very important observation, sometimes till now in any compute exam based on these characteristics it is not framed, but directly you can remember, you may expect in gate exam directly for this type of character. By giving this characteristics, this is the current curve, this is the voltage curve. If it is asked average power loss, friends, directly you remember this formula. 1 by 3 V1 I1 T2 into F. Because the voltage is exist only during T2 time. But even though here current is exist, but here voltage is not present. Wherever the both voltage and current is present, for that reason only power losses are takes place. Only T2 time power losses are takes place. And find the area under this curve, friends. This gives the reverse recovery charge. By finding the area under this curve, I got 1 by 2 into I1 into T1 plus T2. This is the reverse recovery charge. These two formulas you have to concentrate with respect to these characters. Directly also we can expect in gate exam. Yeah, this about the what exactly dynamic characteristics or switching characteristics. One more important concept with respect to SCR gate characteristics. What are the gate characteristics of SCR? What are the observations from gate characteristics? Also very important for gate point of view. Already questions are framed. What do you mean by gate characteristics? The gate characteristics are that those are the characteristics between VG and IC. Students, we know that this VG and IC is applied across one PN junction. That's why the SCR gate characteristics are similar to diode characteristics. A diode characteristics are nothing but which characteristics? Non-linear characteristics. That's the reason why SCR gate characteristics also non-linear characteristics. Practically it's a non-linear characteristics. Very important. SCR gate characteristics are similar to PN junction diode characteristics. We know that diode characteristics are the non-linear characteristics. That's why SCR gate characteristics also non-linear. From these SCR gate characteristics, these observations are important. What is the VGM? What is the IGM? What is the VGMN? What is the IGMN? This is the maximum gate voltage, maximum gate current. Minimum gate voltage, minimum gate current. What is the VNG? That is also important to eliminate the unwanted triggering due to noise signals. That VNG voltage is very gate non-triggering voltage. All these are calculated by drawing the gate character. I'm not explaining how to draw that. Okay, because this is the quick revision only. Important points only that you have to concentrate. Okay, these points mainly you have to concentrate from the gate characteristics. Very important, a non-triggering voltage is specified by the manufacturer to eliminate the unwanted triggering of the SCR due to noise signals. That is the non-trigger. Always we have to maintain the voltage across the gate is less than the non-trigger voltage. If you maintain greater than non-trigger voltage, then the SCR gate terminal is unwanted triggering. To eliminate that problem only, that is specified by the manufacturer. And very important is this, based on this circuit, surely you can expect the question. Here the difference between these two circuits is, here the resistance is not connected between gate and cathode terminal, but here the resistance is connected. If the resistance is not connected, whatever this IS current, IC currents are equal. But if any resistance is connected, this IS current is divided as IR and IC. Then you apply KVL in this loop, we can get this equation. Apply KVL in this loop and IS equal to IR plus IC, then we can get this equation. Just circuit theory concept. This is the DC triggering circuit that you have to consider. This is the gate characteristics and finding the operating point. For that reason, let's consider the one SCR. For that SCR, then this is the source voltage equal to VG plus IC into RS. This is the case without any resistance between gate and, if any resistance is connected, use this formula that you have to consider. Then by finding the operating point, how to find the operating point, no need to remember. From this, I written some observation that you have to concentrate. That is, the operating point is always in between 1 and 2 only. The operating point is in between 1 and 2 only. This line is called load line. In SCR gate characteristics, what the load line slope? It is having the negative slope. And very important observation, the slope of the load line in SCR gate characteristics, the slope of the load line indicates gate source resistance. What is the slope of the load line indicates? The slope of the load line indicates the gate source resistance. This is the slope of the load line. The slope of the load line is negative. Why it is a negative slope? Because of falling slope. Because of the falling slope. The SCR gate characteristics are linear characteristics or non-linear? The non-linear character. This observation is important. The SCR. For example, if the question is asked like this, the slope of the load line is minus 300 volts per ampere. What is the gate source resistance? Slope of the load line, students. I'm not telling about the slope of the gate characteristics. Gate characteristics are positive slope because it's a rising slope. These are the gate characteristics. But this is the load line characteristics. Load line characteristics are falling slope because these are the negative slope. Falling slope, that is a negative slope. Then if you find the slope of this load line, that slope of load line directly gives the gate source resistance. Gate source resistance. And some important observation that I given, gate characteristics are non-linear. SCR gate characteristics are having positive slope. SCR gate characteristics are having positive slope. If the load line is tangent to PZAV curve, this load line I given, if this load line is tangent to this PZAV curve is average power dissipation curve. If this is tangent to this curve, this PZAV curve, this slope of this load line indicates the minimum value of gate source resistance to reduce the turn on time or jitter. And if ideally if the gate characteristics are linear, how to find the slope? Vz by Z. This observation is important during solving of the problems. Generally, no doubt at all, gate characteristics are non-linear. Now what the point I am telling, if they given the characteristics like this is the characteristics passing through horizon, then how to write the gate characteristic slope? Vz by Ic. If the load line is tangent to PZAV curve, what the slope of tangent indicates, friends? Minimum value of gate source resistance to reduce the turn on time or jitter. Then, if the slope of the load line is minus 120 volts per ampere, slope of load line is minus, then what the source resistance? I told already, slope of the load line directly indicate the source resistance, gate source resistance, 120 volts. Like this we can expect the question that you have to consider. But point you have to remember, what about the supply we are giving to the gate? Based on that, the gate triggering methods are classified into DC triggering, AC triggering, pulse triggering. But DC triggering is having so many drawbacks. That's why mainly we are preferring the pulse triggering. Yeah, this is the DC triggering. In DC triggering, we are connecting the continuous DC supply. Because of continuous DC supply, it adds additional power loss. That is one problem. There is no isolation between the power circuit and gate terminal. And one more drawback is, by using one gate circuit, only one SCR is triggered. Yeah, these are the drawbacks of DC triggering because it leads to more power loss also. These are the drawbacks of DC triggering. Because of continuous supply, it adds additional power loss. DC triggering, there exists additional power loss. There is no isolation between power circuit and gate terminal. That is a problem. At a time, only one SCR is triggered. In DC triggering, the average gate power loss equal to maximum gate power loss. That is, there exists a maximum power loss. That is the drawback. To overcome these drawbacks, mainly we are using the AC triggering. In that AC triggering, pulse triggering is very important. This is the pulse triggering circuit. This is the theoretical circuit. This is the practical circuit. The purpose of D1 diode and D2 diode that I given, please go through this point. This D1 diode eliminates the entering of leakage current to the transformer. D2 diode provides the path for energy stored in the primary that is dissipated in the resistor. That is practical circuit. We have to take some precautions. That extra D1, D2 diodes we have. This pulse triggering circuit generate the pulses. These pulses are applied to the pulse transformer. Now, what is the advantage of pulse triggering? We can trigger more number of SCRs at a time by using center tapped arrangement at second. That is one advantage. Yet there is no continuous power loss now, because we are applying pulse. Whenever triggering is required, we can apply the pulse, then remove the pulse. That's why only on time only power loss. Off time there is no power loss. There is no continuous power loss. That is the advantage. One more advantage is because of this transformer, it is called isolation transformer. Na? Because of this isolation transformer, there is isolation between power circuit and gate terminal. But this is not present in DC triggering, because for DC triggering, we don't use the transformer. Don't use the transformer. Here, advantage of pulse triggering again. There is no continuous power loss. There is isolation between power circuit and gate terminals. At a time, more number of SCRs can be triggered. This is the connection for how to trigger the more number of SCRs at a time using pulse triggering circuit. In a pulse triggering, this is very important formula. This is important. What is the average gate power loss in a pulse triggering? Vg into Iz into Tn by T. Vg into Iz into 1 by T I written as F. Tn into F. This, what is Vg into Iz? That I told PGM. Vg into Iz equal to PGM, where PGM is the maximum gate power loss. That is one more formula for average gate power loss is PGAV equal to PGM into Tn into F. Tn into F, where F is the switching frequency. We can also write like this. What the Tn by T, friends? This Tn by T is the duty cycle. Tn by T is the duty cycle. Then if you replace Tn by T is the duty cycle, VGIZ is the PGM, then this is PGM into delta. This one more formula. This formula you have to remember. This formula you have to remember. Different ways of writing the formula. Average gate power loss. Next. How to define the duty cycle? The duty cycle is, you have to use the different symbols for denoting the duty cycle. You can use alpha. Different authors, they are following the different notations. Na? Alpha, delta, K, T. Any notation you have to. Then duty cycle equal Tn by T. If the duty cycle equal Tn by T, on time equal to, what are the on time, friends? Is Tn equal to delta into T. Delta into T. Then what the T of equal to? T of equal to 1 minus delta into C. That is T of equal to 1. This important observation during solving of the problems. Once you know the Tn and T of, very important terminology, Mark II space ratio. Instead of asking Tn by T of, they are asking that Mark II space ratio. If they ask the Mark II space ratio means, Mark means Tn, space means T of. This is Tn equal delta into T. T of equal to 1 minus delta into T. This I substituted. This is the Mark II space ratio. Whatever the 5 star I given, that points mainly you have to know. Then what is the pulse transformer? What is the observations from pulse transformer? In gate triggering, the main purpose of using the pulse transformer is to isolate the power circuit and gate. Very important. What is the purpose of using pulse transformer? To isolate the power circuit and the gate terminals. And one more important point that you have to concentrate. The core of the pulse transformer is made with the ferrite core. Which material is used for manufacturing of the core of the pulse transformer? Ferrite core. Why we are using ferrite core? To reduce the hysteresis and eddy current losses at high frequency. What the turns ratio of pulse transformer? We may expect 1:1, 1:1:1, or 2:1:1. These are represented with the center tapped arrangement. With the center tapped. If you are using any center tapped arrangement at pulse transformer, you can represent like this. If there is no center tapped arrangement, you can represent like this. Pulse transformer is designed for high frequency, size is reduced. Very important. That's I told now. If you use high frequency pulse triggering, then transformer are also designed for high frequency. Friends, we know that if any transformer is designed for high frequency, the size of the transformer is less. Why? Because, see the one simple example. In our power system, we are using transformer at 50 Hz. In communication system, in radios and TVs also, there is a transformers. Where the transformer size is very small in communication system or radios and TVs. But in a power system, the transformer size is more because frequency is low operation. Low frequency operation. 50 Hz frequency. But in communication system, that is operate for kilohertz and megahertz frequency. That's why the size of the transformer is. If any transformer is designed for high frequency, I'm not talking during operation. Once we can design, the size will not change, sir. I'm telling that during design, if any transformer is designed for high frequency, that transformer is less size. And very important observation, this is the equivalent circuit of pulse transformer. From the equivalent circuit of pulse transformer, this formula you have to concentrate. This is the equivalent circuit refer to primary. I transfer the what are the parameters in the secondary side, transfer to the primary. RG becomes RD dash, VG becomes VG dash. If you are transferring secondary to primary, that is divided by K square. Resistance is divided by K square. Voltage is divided by K, where K equal to N2 by N1. If N2 N1 is not given, generally it is a isolation transformer. Na? We have to use the 1 is to N2 equal to 1 is to 1 square. If they don't given, if they given, according to that only can. And this formula you have to concentrate. Based on this formula, in one of the standard textbooks, some questions are there. Then I told already the size of the pulse. If any transformer is designed for high frequency pulses, size of the pulse transformer is reduced. Turn on time is reduced. Both A and B is correct if they given. If they not given, first preference is size of the pulse transformer is reduced. Next, what the purpose of using this diode and what the purpose of using this diode? This is the clamping diode. A diode in series with gate circuit prevent the flow of negative gate source current from becoming more than small reverse leakage. That's the purpose of using series. But the purpose of using clamping diode, it eliminates the voltage become more than 1 volt. Yes, friends, that is the purpose of using clamping diode. What the purpose of using resistance across gate and cathode terminal? A resistance across gate and cathode terminal bypass the leakage current. If it is bypass the leakage current, very important, 5-star observation. If that resistance bypass the leakage current, noise immunity increases, thermal stability increases, it raises the latching and holding current levels, dV by dt capability. If all are given, all the above answer is given, all the above is the right answer. Even though all are given, but all the above is not the option, but preference is noise immunity is increased. Noise immunity is increased. At that point you have to concentrate. If that is MSQ questions, then you select all the question. All the options are correct. That is MSQ question given. Noise humidity increases, thermal stability increases. That is raise the level of latching current and holding current, dV by dt cap. So increases by connecting the resistance across gate and cathode terminals. And whatever the observations I given students, based on that observation, I solved some problems here. Please go through all these questions. You have to practice this. This is your final preparation of power electronics for your exam point of view. Whatever the points again, please note down that points. Try to practice these questions with that knowledge. And that I given whatever the observations, based on this, you have to try to solve this problem. And this problem also you have to try to solve. This is the formula based questions that you have to concentrate. And one more important question that I given, this is also formula based question that you have to concentrate. All the formulas that I given in the concept explanation. And by connect, this is the important model of question. This is the expected model of question in your gate exam point of view. Please try to practice this question. Now, this question we can easily solve by using circuit theory concept. Just KVL and KCL only how to apply, then we can easily solve. For this circuit, how to apply these equations I already given. Please go through that formula. And this is the previous gate question. You try to solve this question also. Here they given 10 volts, drop is 1 volts, remaining is 9 volts. It is 1 is to 1. If it is a 9 volts, this is also 9 volts. And voltage across the diode is given 1 volt. This R. Here IC given both minimum and maximum. If both minimum and maxima is given, you select the maximum values. How to select the IC maximum value. Then apply KVL in this loop. Apply KVL in this loop. Then you have to find the resistance equal to 47 ohms that you have. Then if VG IC characteristics are linear, then VG by IC equal to directly indicate the slope, and VG IC given. Solve these two equations, we can get VG and IC values. We can get the VG and IC values. Once we can get the VG and IC values, then we can solve for the RS value. One more problem that you have to practice. And this also you have to practice, friends. This also based on the VG IC characteristics only. VG and IC characteristics. Here it is asking the delta value. that I solved. Please go through this problem. You have to concentrate. Try to practice these questions. Try to practice this question. And this is the question based on the equivalent. This is the expected model of question in our gate point of view. Please try to. For this, I already given the formula Vg dash equal to Vp into Rg dash by Rg dash, that you have to concentrate. If this R is the resistance at primary side, Rg dash is the resistance referred to primary. We are transferring from secondary to primary. That you have to calculate. From this, we have to calculate the what the Vg dash equal Vp. It is asking that primary voltage. Primary voltage is 16.5 volts is the answer for this question. With this, what is the observation from SCR gate characteristics? What the DC triggering? What the AC triggering? In AC triggering, what exactly pulse triggering? What are the observations from pulse triggering? One more important concept with respect to SCR is what the SCR protection circuit. Friends, we know that during the operation, SCR is subjected to various abnormal operating conditions. To protect the SCR from those abnormal operating conditions, we have to use some protecting elements. The circuit breaker and fast acting current limiting fuse. Very important. Circuit breaker and fast acting FACLF fuse is fast acting current limiting fuse used for overcurrent protection. An inductor in series with SCR. Inductor connected in series with SCR, that is used for di by dt protection. Very important. Di by dt protection. Next. Snubber circuit is used for dV by dt protection. What the purpose of using snubber circuit dV? This MOV, metal oxide varistor, or thyrector, or non-linear resistor. This is used for to protect from over voltage. Each element for which purpose we have to use that concept. Heat sinks are used to protect the SCR from temperature rise. Heat sinks are used to protect the SCR from temperature rise. Snubber circuit for dV by dt protection. Metal oxide varistor, MOV, non-linear resistor. It is used for which protection? Over voltage protection. Di by dt protection and inductor in series with SCR. Snubber circuit is connected across the SCR, but inductor is connected in series with SCR. Circuit breaker and fast acting current limiting fuse is used for overcurrent protection. The point you have to remember, students, the total SCR gate is very sensitive element. A separate protection scheme is employed for gate element. Additionally, there is extra elements are added in the gate element R2 to limit the high currents. That is to protect the gate from high currents. To protect the gate from high currents. To protect the gate from high currents, we have to use the R2 resistance. Zener diode is to protect the gate from high voltage or over voltage. We have to use Zener diode, gate from high voltage. To protect the gate from high voltages, we are using the Zener diode. RC filter. This RC filter is, RC filter to bypass high frequency noise signal. To bypass high frequency noise signal. High frequency noise signal. That is the purpose of using the RC filter. You have to concentrate. This is the what is the protection of each element that I told already. Di by dt protection. Di by dt protection, an inductor is connected series with the The typical di by dt values are 20 to 500 amperes per microsecond. What the range of di by dt? 20 to 500 amperes per microsecond. What is the property of inductor and capacitor that you know? That is, initially inductor acts as an open circuit, finally it is a short circuit. Initially capacitor acts as a short circuit, finally it acts as an open circuit. These are the capacitor properties. Capacitor properties, and this is the inductor property that you have to concentrate. At di by dt protection, we are using inductor. Then what about the dV by dt protection? For dV by dt protection, we are using the snubber circuit. To protect the SCR from dV by dt, we are using the snubber circuit. A snubber circuit is typical values of dV by dt is 20 to 500 volts per micro. What is the range of dV by dt? That is also very. False turn on of thyristor by large dV by dt can be prevented by using snubber circuit in parallel with the device. This is important. Snubber circuit is in parallel. A series RC combination across SCR is called snubber circuit. What exactly is snubber circuit? For dV by dt protection, we have to use series RC combination. A snubber circuit suppress or reduce the dV by dt during turn off. This is important. Even an inductor in series with SCR, reduces or suppress. It cannot eliminate. Very important. Inductor reduces or suppress the di by dt. It cannot eliminate the di by dt. Even snubber circuit also suppress or reduces the dV by dt. Not completely eliminate the dV by dt. This is during off time. Inductor is during on time. Temperature protection. To protect the SCR from high temperature rise, we have to use the heat sink. If there is a very high temperature rises are there, we have to use the external cooling methods, that is water cooling and air cooling methods we use, that is for temperature protection. What are the gate protection scheme? Told already, the total SCR gate is very sensitive element. To protect the gate terminal from various abnormal operating conditions, R2 resistor is in series with the gate circuit, overcurrent protection. GNR diode that I told, GNR diode for high voltage protection from the gate terminal. That is, to protect the gate terminal from high voltages, we are using GNR diode. A common problem in thyristor circuit is that they suffer from spurious noisy firing, noisy signals. Sometimes transient in a power circuit may also cause unwanted signal to appear across the gate of neighboring SCR. To protect the SCR from these unwanted signals, we have to use by using shielded cables or twisted gate leads. That is, whatever the gate terminals are there, these are designed with separate gate leads. Those are nothing but a twisted gate lead. To protect the SCR from the spurious signals, unwanted trigger, to eliminate the unwanted triggering. Then the purpose of using twisted gate leads is it can minimize by using the twisted gate leads. That is, whatever the spurious signal effect is there, that can be minimized by using the twisted gate. A capacitor and resistor also connected across gate to cathode to bypass the noise signal. That is a high pass filter. The RC filter bypass the high frequency noise signal. That is a separate protection scheme is employed for the gate. But here note point to remember, students. There is so many abnormal operating conditions are there. In that abnormal operating condition, overcurrents, over voltages, dV by dt, di by dt, temperature rise. These effects causes permanent damage of SCR. Causes the permanent damage. But dV by dt is causes only unwanted triggering, but it cannot causes permanent damage of SCR. dV by dt cannot causes, this is important, which cannot causes the permanent damage of SCR. It cannot cause the permanent damage. These points mainly hold. There is one more protection scheme, electronic crowbar protection. This electronic crowbar protection, we are using crowbar thyristor. What do you mean by crowbar thyristor? A high current rating thyristor is called crowbar thyristor. Whatever the high current rating thyristors are there, those thyristors are called crowbar thyristor. This electronic crowbar protection is used to protect the total power electronic converter from overcurrents. To protect the power electronic converter from overcurrents, we can use the electronic crowbar protection. Next, what are the formulas related to the snubber circuits? This is very important. A snubber circuit suppress or reduce the dV by dt during off time. What is the purpose of using snubber circuit? A snubber circuit is nothing but a series RC combination across the SCR. Friends, no doubt at all. A single capacitor is enough to reduce the dV by dt. But in series with the capacitor, we are also connecting the resistance to limit the discharging current of the capacitor. That is very important. What is the purpose of using the resistance in series with this RS is snubber circuit resistance to limit the discharging current. Even capacitance itself will limit the dV by dt. But why you are connecting RS sub extra to limit the discharging current? But actually RS is required during discharging of the capacitor only. But it is not required during charging of the capacitor. To bypass this resistor during charging of the capacitor, the diode is connected. That is, if the capacitor is charging, through diode it will charge. Yes, friends. If the capacitor is discharging, through resistor it will discharge. Then limit the discharging current. This is about the snubber circuit. Here there is two types of snubber circuits are there. Snubber circuit without diode connection. In some snubber circuit don't use diode. That is called unpolarized snubber circuit. Snubber circuit without diode. Snubber circuit with diode is called polarized snubber circuit. These polarized snubber circuits are again forward polarized to protect from forward dV by dt. Reverse polarized to protect the SCR from reverse dV by dt. This is important. What point you have to remember? Generally, snubber circuit is nothing but RC combination. Why you are using resistor? To limit the discharging current. Why you are using diode? Actually, the resistor is required only during discharging of the capacitor. I don't want diode during charging of the capacitor. If during charging of the capacitor, if the resistance is present, power losses are increases, time constant is increases. That is the problem. That's the reason why during charging of the capacitor, we have to bypass this resistor. For that reason, we are using diodes. At this point, you have to remember. With respect to snubber circuit, this is unpolarized snubber circuit. The two thyristors are anti-parallel. We have to use unpolarized snubber circuit. This is a forward polarized snubber circuit. This what this forward polarized snubber circuit consists. All this concept you have. This is used for the forward dV by dt protection. This is the reverse polarized snubber circuit. It is used for the reverse dV by dt protection. Next. This is very important formulas to solve the problems. I don't want to give the detailed explanation here, derivations, all these. This is one formula you have to remember, students, to design the capacitance value. And this also one more formula to design the capacitance value. This is the formula you have to use to design the resistance value. This is the formula you have to use to design the inductance. Actually, V equal to L into di by dt. From this formula, you have to design the L value. I equal to C into dV by dt. From this formula, you have to design the capacitance value. Or you can also design the capacitance value using this formula. And this is the design of the resistance value, L by Vs into dV by dt. This formula is meaning. If zeta is not given, where zeta is the damping ratio, if the zeta is not given, you have to take the zeta equal to 0.65. For optimum results, you have to take the zeta equal to 0.65. Zeta equal to 0.65. Generally, what is the range of damping ratio in snubber circuit? 0.5 to 1. If they don't given any zeta value to design the snubber circuit parameter values, then take the zeta equal to 0.65. By considering the zeta equal to 0.65 only. What are the applications of snubber circuit? It suppress or reduce the dV by dt. A snubber circuit suppress or reduce the dV by dt. It reduces the time taken for latching current and turn on process is improved. That is, because of the snubber circuit, if there is a snubber circuit, there is a two currents, supply current and capacitor current. Then within less time, the current is rises to latching current. Then the turn on process is improved. Within less time, the SCR will be turned on. That is also advantage. Because of two currents are present. It equalizes the dynamic characteristics of the device. Reduce the dV by dt. It improves the turn on process. It equalizes the dynamic characteristics of the SCR. Because without snubber circuit, only one current. To rise the latching current, it takes more time. With the snubber circuit, there is a two currents. To rise the latching current, within less time, the current will be rises to latching current. The turn on time is improved. Then what are the observations that I given, students? Based on that observations, I given some questions. Please go through these questions. Practice these questions. Whatever the points I given. And these are a design of snubber circuit. L design, RS design, CS design. Please practice this problem also. Important for your exam point of view. how to design L value, RS value and CS value. If zeta is already given here, zeta is not given, you take the 0.65. If zeta is not given. Even sometimes load resistance, they will do load resistance not given. If load resistance is not given, you take the 0 value. Load resistance is not given, the 0 value. And this also one more problem based on the snubber circuit that you have to concentrate. This is the formula for the, that is, here it is asking the dV by dt and di by dt. dV by dt how to calculate, di by dt how to calculate. But here in this calculation, you have to use the maximum value. You have to substitute the maximum values. Substitute the maximum value. If AC supply is given, you have to consider the maximum value. Next. With this, that is the protection circuit of SCR completed. One more topic with respect to SCR is heating and cooling circuit. What do you mean by heating and cooling circuit? This heating and cooling circuit of SCR explains how the heat is produced in the SCR. Whatever the heat is produced in the SCR, how it is transferred to the ambient environment. How the heat is produced, that is heating. How the heat is dissipated into environment, that is the cooling. Generally, heat is produced at the junctions. In SCRs, where the heat is produced? At the junctions. It is transferred from junction to casing. Casing means total material. Casing to sink. Sink means that SCR is mounted on heat sink. That is sink. From that sink, it is dissipated into environment. That is, the heat transfer is similar to charge transfer in a series electrical circuit. That's the reason why there is a similarities between the electrical circuit and thermal circuits. Heat is produced at the junctions. Heat is produced at the junctions. It is transferred from junction to casing. Casing is total material, it is transferred. Junction to casing, it is transferred. This is junction. It is transferred to casing. From casing to sink, this is the heat sink. It is transferred to heat sink. And heat sink to ambient, it is dissipated into environment. Ambient is nothing but it is dissipated into environment. Where it is produced? At the junctions. From junction to casing. Casing means total material, it is transferred. This is the heat sink. Hence, there is a similarities between thermal system and electrical system. What are the similarities, friends? In electrical circuit, charge, that is equivalent to heat in thermal system, heat energy in thermal system. In electrical circuit, rate of charge transfer, that is current, that is rate of heat transfer, that is thermal power. Current is equivalent to thermal power. What are the units of current? Coulomb per second, here joule per second, amperes or watt. But the potential difference, that is in electrical quantities, there is a concept of voltage, potential difference. But here temperature, that is potential difference is equivalent to temperature difference in thermal system. Electrical resistance, potential difference by current. Thermal resistance denoted by theta students. Thermal, this is important. Thermal resistance, based on this question is there in GATE exam. Thermal resistance is denoted by theta. Theta equal to temperature difference by thermal power. Temperature difference. Because the potential difference is nothing but a temperature difference. Current is nothing but a, here current, this side thermal power, no? This side thermal. That is temperature difference by. Like this, we have to compare electrical quantities, and with this knowledge, we draw the equivalent circuit. This is the heating and cooling circuit of yeah. This is the thermal resistance formula that you have to come. That is the temperature difference by thermal power. That is the thermal resistance formula. Heat is produced from junction to casing. Produce junction, it is transferred junction to casing, casing to sink, sink to ambient. This is the junction temperature, casing temperature, sink temperature, ambient temperature. During heat is transferred, this heat is opposed by resistance, that is the thermal resistance. Theta JC, junction to casing, theta CS, casing to sink, theta SA, sink to ambient. And one more important point you have to remember, friends, what are the units of thermal resistance? That's very important. The units of thermal resistance is degree centigrade per watt or degree centigrade per joule per second, or it is also Kelvin per watt or Kelvin per joule per second. Then from this equivalent circuit, using the concept of electrical circuit, Here instead of voltages, you have to take the temperatures. Instead of resistance, you take the thermal resistance. Instead of current, you take the power, thermal power. Then using this applied here, then average thermal power equal to, for example, I am defining junction to casing. If you define from junction to casing, Tj minus Tc by theta Jc. If you define from casing to sink, Tc minus Ts by Tc minus Cs theta Cs. If you are defining from sink to ambient, Ts minus Ta by theta Sc. If you define from junction to ambient, if you are writing from junction to ambient, between this all the resistance you have to add. If you are defining from junction to sink, between this all the resistance, theta Jc plus theta Cs, theta Jc plus theta. This also equal to theta Js, junction to sink. Theta Js is nothing but a junction to sink. Junction to sink, how much resistance? Jc plus Cs, C plus C. Then this is the total thermal. This formula is very important to solve the problems. Mainly, these formulas are important in this concept. And based on these formulas, how to solve the problem that I given, please go through that. Before that, the question is asking that heat sinks are made with which material? No doubt at all, heat sinks are made with either copper or aluminum. But copper is costly, that's why, which is more economical for manufacturing of the heat sinks. Aluminum is the more economical for manufacturing of the heat sinks. That you have to concentrate. Next. And one more important observation. By providing the forced cooling methods, not only heat sinks, along with heat sinks, if you use the forced cooling methods, same device can be used for high rating application. For example, without forced cooling, let the device is using for I1 current, power loss is PAV. With forced cooling, we can use for high current. No doubt at all. If the high current rating, power loss will increase. But even though power loss increase, because of that power loss rise in temperature, that temperature is limited by forced cooling. That's the reason. That is, with forced cooling, we can use for high rating application. With forced cooling, once we are using for high rating, current increases, power loss increases. No doubt at all. But even though power loss is increases, due to increase of that power loss, whatever the temperature rise is there, that is limited by forced cooling. There is no problem. But what the point you have to remember, students? Due to forced cooling, how much percentage increase in the device rate? The same device can be used for high rating application now. What the percentage increase? This is the formula. But this current I am writing in terms of power, because P is proportional to I square, I is proportional to root P. I2 is replaced by root PAV2. I1 is replaced by root PAV1 by root PAV1 into 100. This is the percentage increase in device rating due to forced cooling. That is, by providing extra cooling method or by providing efficient cooling methods, same device can be utilized for high rating application. Then I given some problems here. Which of the following is used for aluminum? Can use. And what the definition of thermal resistance is also asked. We have to concentrate. And I solved one problem also. Please go through this problem. Already these formulas I given. So please try to practice this question also. And you try to practice this model of problem also. You have to try to practice. All the formulas that I given. With this T is equal to 62 degrees centigrade. This solution I given. Please go through. This is one more problem. One more example. This for this example you try this one. This one more example. This T is equal to 62 degrees centigrade. Then this model is important for your exam. Gate point of view, this is important. Please practice this question. This is a gunshot question. The expected model of question for your gate point of view. That is important. With this, heating and cooling circuit of SCR is complete. One more important concept with respect to SCR is series and parallel connection of SCR. Friends, what is the purpose of using series and parallel connection? In some industrial applications, single SCR cannot fulfill the required demand. In that case, it is required to connect the SCRs in series and parallel. SCR series connection is used, series connection. SCR series connection is used to meet high voltage demand. Because in series connection, voltage is added. SCR parallel connection is used to meet the high current demand. High current demands are met by the parallel connection. High voltage demands are met by the series connection. High voltage demands are met by the series connection. But whatever may be the connections, SCRs connected in a string must be maximum utilization. How much percentage it is utilized, that is measured by string efficiency. This is the string efficiency, very important. The string efficiency is defined as it is a measure of degree of utilization of SCR string. Then what is the string efficiency for series connected SCRs? This formula you have to remember. Voltage across whole string by number of series connected SCRs into individual voltage rating of single SCR. Individual voltage rating of single SCR. As a notation, Vs by Ns into V1. String voltage by number of series connected SCR into individual voltage. But for parallel connected SCR, for a parallel connected SCR, string efficiency equal to current through whole string by number of parallel connected SCRs into individual current rating of single SCR. This is as a notation Is by V into I1. If you want percentage into hundreds. This is for series connected SCRs, parallel connected SCRs. Very important formulas. Concentrate. And one more important formula with respect to series and parallel connection is derating factors. How to define the derating factor? It measures the reliability of the string. That is, given string is how much reliable. Very important. Given string is how much reliable. That is measured by the derating factor. Derating factor and string efficiency exactly opposite. For example, let's consider two strings. Design like this. One string is 10 number of SCRs. Each SCR rating is 2 kV, supplying 18 kV demand, 90% efficiency. Another string is 15 number of SCRs. Each SCR is 2 kV but supplying only 18 kV, 60% efficiency. Then no doubt at all, string 1 is more efficient, string 2 is less efficient. But which is more reliable, sir? String 2 is more reliable because it is not fully utilized. If it is not fully utilized, it can work for a long time. No? If the string is fully utilized, it cannot work for a long time. Reliability in the sense, derating factor is reliability. Reliability in the sense lifetime. Which string can work for a long time? String 2 can work for a long time because it is less utilized. That's why efficiency and derating factor is exactly opposite. That's why derating factor equal to 1 minus string efficiency. What is the observation here? Efficiency is increases, reliability will reduce. That is, if derating factor is increases, high reliability. If reliability is more, efficiency is less. To maintain the high reliability, here you see the 15 number of SCRs, here 10 number of SCRs. This is more reliable. String 2 is more reliable as compared to string 1. How we are maintaining more reliable? Because of more number of SCRs. That is, to maintain the high reliability, more number of SCRs we have to maintain. If number of SCRs are increased, what is the cost? Cost is also. That's why high reliability associated with it. But mainly you have to remember this relation. This is about the derating factor. The detailed discussion of series connection. Very important observation you have to remember. Ideally, string efficiency is equal to 1. Practically, string efficiency is less than 1. Practically, string efficiency is less than 1. Why? The reason why it is a less than 1, even though SCRs with the same rating, practically they don't block the same voltage. Due to unequal voltage distribution, let SCR1 is blocking is V1, SCR2 is V2, then V1 plus V2 by. Let assume that highest voltage rating is V1, then high rating you take in denominator. This value is less than 1. That is, string efficiency is reduced. Why string efficiency is reducing? Because of unequal voltage distribution. Because of unequal. What is the reason for unequal voltage distribution? There is so many reasons are there. One reason for unequal voltage distribution is due to unequal static VI. If the two SCRs are blocks the same voltage, we got 100%. But this is only ideal case. Practically, it is never possible. That's why ideally string efficiency equal to 1, practically string efficiency less than 1 because of unequal voltage distribution. What is the reason for unequal voltage distribution? Due to unequal static VI character. Now, in order to equalize these characteristics, that is a unequal voltage distribution is due to unequal this is one reason. unequal voltage distribution is due to unequal static VI character. Static VI characters. That you have to concentrate. Then how to equalize these characters? To equalize this static VI characteristics or unequal voltage distribution, we have to use the static equalizing resistance. What is the static equalizing resistance? A static equalizing circuit consists of one equal resistance across the each SCR. That is called static equalizing circuit. That resistance is called static equalizing. But this derivation part is not required, friends. This is important. That is to equalize the unequal voltage distribution. To equalize the voltage distribution. To equalize the static VI characteristics are unequal voltage. To equalize the static VI characteristics. Static VI characteristics are to equalize the unequal voltage distribution due to static VI characteristics. To equalize the unequal voltage distribution. Equal voltage distribution. Static equalizing circuit we have to. Static equalizing circuit. What this static equalizing circuit consists, friends? Circuit is used. A static equalizing circuit consists of one equal resistance across the each SCR. What is that resistance? R equal to Ns into VBMX minus Vs by Ns minus 1 into delta IB, where delta IB equal to maximum leakage current minus minimum leakage. Ns is the number of series connected SCRs. All the terms that I given, please go through these terms. Ns is the number of series connected SCRs. But the Ns series connected SCR. Vs is the swing voltage. R is the swing static equalizing. VB max the maximum blocking voltage. VBMN is the minimum blocking. IBMN minimum leakage current. IBMX is the maximum leakage current. This formula mainly to remember. Next. What about the dynamic equalizing circuit? What is dynamic equalizing circuit? To equalize the unequal voltage distribution due to unequal dynamics characteristics, we have to use the dynamic equalizer. What this dynamic equalizing circuit consists of? It consists of a dynamic equalizing, this is important. A dynamic equalizing circuit consists of R and C in series and diode across R. This is important. What this dynamic equalizing circuit? It equalize unequal dynamic characteristics. Equal dynamic character. Static equalizing circuit, it equalizes the static characters. What the static equalizing circuit consists? This two important observation. A static equalizing circuit consists of one equal resistance across each SCR. A dynamic equalizing circuit, it is also called snubber circuit. Dynamic equalizing circuit is also called snubber circuit. What it consists? It consists of R and C in series and diode across R. R and C in series, diode across. In this dynamic equalizing circuit, what is the capacitance value? In dynamic equalizing circuit, the capacitance value. You need to write all these formulas, not required. Why there is a unequal dynamic characteristics? Because of charge difference. SCR is having unequal dynamic characteristics because of the charge difference between the two SCR. Then how to design this value? This is the dynamic equalizing capacitance. This dynamic equalizing capacitance is designed by using the reverse recovery characteristics of S. By using the reverse recovery characteristics of SCR. Then what the dynamic equalizing capacitance? Ns minus 1 into delta Q by. Sir, whatever the 5 star I given, that point only how to know. Ns minus 1 into delta Q by Ns into VBMX. For time being, I am not giving. This is a quick revision. No need of all. These are derivation points. Ns minus 1 into delta Q by Ns into VBM. This point mainly. Then dynamic equalizing capacitance is calculated by using reverse recovery character. SCR with high leakage current, blocking voltage less. That you know. The leakage current is more, blocking voltage is less. SCR with high leakage resistance, blocking voltage is high. Leakage resistance is high means leakage current is less. Leakage current is less means blocking voltage is more. Yeah, this is the formula for static equalizing resistance. This is the formula for dynamic equalizing capacitance, where delta Q is the charge difference. This delta Q is the charge difference. Next, parallel connection. Even for parallel connected SCRs also, the string efficiency is less than practically. Ideally, string efficiency equal to 1. There is unequal current sharing due to unequal static characteristics. Because of this unequal current sharing, if current sharing is equal, we can get 100%, but not possible practically. Because of unequal current sharing, there exists a string efficiency less than 1. You have to equalize this current sharing. In order to equalize the current sharing for DC circuits, in series with each SCR, we have to connect the one resistance. How to equalize the current sharing in DC circuits? You have to connect the resistance in series with each SCR. Then what is that resistance value? Next, for AC circuits, you have to connect a center tap reactor. This circuit can work according to Lenz's law. Very important. For DC circuit to equalize the current sharing, unequal current sharing due to unequal static VI characteristics, you have to equalize this current sharing. DC circuits you have to use resistor. AC circuits you have to use center tap reactor. This circuit can work according to Lenz's law. That point only you have to remember. Which you can use center tap reactor you have to use. Then due to unequal dynamic characteristics also, current sharing becomes unequal. Once the current sharing becomes unequal, then the string may be damaged. This is important. What is the effect of unequal dynamic characteristics in parallel connections? In a parallel connection, due to unequal dynamic characteristics, the total string may be damaged. Then what is the remedy for this problem? Solution for this problem? You have to use the synchronized triggering. In parallel connection, due to unequal dynamic characteristics, the total string may be damaged. If for all the SCRs triggered is applied at a time, if all the SCRs are triggered at a time, the total string may be damaged. So, what is the remedy for this problem? You have to use the synchronized triggering. What do you mean by synchronized triggering? You have to trigger the SCRs in such a way that all the SCRs must be turned on at a time. You have to give the triggering according to their turn on time. Don't give the triggering all the SCRs at a time. You have to give the triggering according to their turn on times. That type of triggering is called synchronized triggering. What is the problem with unequal dynamic characteristics in a parallel connection? Total string is damaged. What is the remedy for that problem? Synchronized triggering. In a parallel connection, due to unsymmetrical mounting, the unsymmetrical mounting also, current sharing becomes unequal. Unsymmetrical mounting, current sharing becomes unequal. Because if it is unsymmetrical mounting, for middle SCR, middle conductor, more flux linkage, current sharing becomes unequal. Because of more flux linkage, more impedance, current sharing becomes unequal. This type of mounting is called unsymmetrical. That is, in a parallel connection, due to unsymmetrical mounting, current sharing becomes unequal. To equalize the current sharing, you have to use the symmetrical mounting. This type of mounting is called symmetrical mounting. That is the problem, and this is the remedy. In parallel connection, what is the problem? What is the remedy that I given? Then this is the summary points with respect to series and parallel connection of SCRs that you have to concentrate. Ideally, string efficiency is equal to 1, but practically less than 1. To get the high string efficiency, voltage distribution across the must be equal. That's very important. Because of unequal voltage distribution or unequal current distribution, only string efficiency is reducing now. To get the high string efficiency, voltage distribution is equal in series connection, current distribution is equal in parallel connection. Static equalizing circuit consists of one equal value of resistance across each SCR. This is important. What is static equalizing circuit? One equal value, not different values across each SCR. SCR with less leakage current blocks the high voltage. Leakage current is less, blocking voltage is more. SCR with high leakage resistance blocks high voltage. Leakage resistance is more means current is less. Then it blocks the high voltage. A dynamic equalizing circuit consists of series RC and diode across R that you see in dynamic equalizing. This dynamic equalizing circuit is also called snubber circuit. Dynamic equalizing capacitance calculated based on reverse recovery current. All these points that I give. An SCR with least Reverse recovery time will share highest transient voltage. Static equalizing resistance formula, dynamic equalizing capacitance formula, string efficiency for series connected. This is for series connected SCR. This is for series connected SCR. And this is for parallel connected SCR. For parallel connected. String efficiency for parallel connected. And this is a formula for derating factor that you have to consider. Friends, whatever the observations that I given in series and parallel connection, I given some problems. Please go through this problem. Practice these questions. Practice these questions. This is your final preparation with respect to series and parallel connection. Then how to solve all these questions to practice. Whatever the points I given, whatever the formulas that I given, that is enough to solve all these questions. You have to consider. This model of question is very important. Maximum, even for gate point of view also, is asking that series connected SCRs and parallel connected SCRs by giving string efficiency or by giving derating factors. By giving string efficiency or derating. Here I solve the based on the, that is a static equalizing resistance. How to calculate the static equalizing resistance? I solved one model of question that you have to concentrate. How to calculate the dynamic equalizing capacitance also I solved. Please go through these problems. And this is the question based on the parallel connection of SCRs. Parallel connection of SCRs. This also one more question based on the parallel connection of SCRs. In parallel connection, voltages are equal. Voltage across this branch equal to voltage across this branch, we can equate, we can get the current. Very simple. This is the previous gate question. This is the previous gate question. This is about the detailed discussion of the series and parallel connection. Yes, friends, with this, with respect to power semiconductor devices concepts, in this session I discussed about turn-on methods, dynamic characteristics, gate characteristics, protection circuit, and I explained about heating and cooling circuit, series and parallel. There is three more concepts are there with respect to devices. After completing that only, I will start the rectifiers concept. Three more concepts are, one is commutation methods. That is one concept with respect to devices. And one more is firing circuits, R firing circuit, RC firing circuit, UJT firing circuit. And finally, ratings of SCR. After completing that one, then we can enter into the second chapter, that is the rectifiers concepts. This is about the session. Thank you.